A loan of $490,000, amortized 30 years, payments at the end of each month, interest rate of 9.3%, compounded monthly. Complete the calculations and amortization tables and answer the following questions. So first, enter the details of the loan. Principal $490,000. We're entering all of these as positive numbers. 30 years, annual rate 9.3%, monthly payments. Calculate the payment amount. Reference the cells from the loan information, and your payment needs to turn out to be a positive number. So payment rate, but it has to be divided by 12. Periods is 30 times 12. And we need to reference those cells for that. Present value, future value, and type. But make it positive. Use the fill feature to enter the payment number for 360 payments. I'm going to have this be a sequence, 30 times 12. And that will go up to 360. Reference the previous ending balance. To get the next beginning balance, copy and paste it down. And since we don't have any ending balances, then the rest of those will be zeros. Calculate the interest owed for payment 1. Copy and paste it down. Interest will be beginning balance times by the interest per period. Interest per period is the annual rate. Lock that, divided into 12, and lock that so that I can copy it down. And it's hard to tell right here because they're all zeros. Reference the payment. Write the reference function. Okay, so I have this equal payment amount locked. Principal write down. There we go. Principal write down is payment subtract interest. Copy that down. Calculate the ending balance. That's your beginning balance less, that's click in it, activate it. Your beginning balance less the principal write down. And when I copy that down, all the beginning balances will update. Let's verify that we have a 0 at the end. Yes, so that's good. Use a function in cell C10. Calculate the total payments made over the life of the loan. Okay, I'm going to assume that this wants a sum of the payments. Total interest paid, sum of the interest column. Enter the details for the loan if it was taken out for 15 years. Okay, so principal, $490,000, 15 years, annual rate, 9.3%, monthly payments. Calculate the payment amount, make it a positive number. So opposite of rate has to be divided into the rate per period, so divided by 12. Number of periods is now 15 times 12. Future value, or present value, is here. Future value, 0. Type, end of the period, which is 0. Use the fill feature and enter the payment number. This will be a sequence. Click to put the focus there. Sequence, 15 times 12. I should now get a sequence that only goes to 180. Reference the previous ending balance for the beginning balance. Calculate the interest owed. Beginning balance times by interest rate divided by 12. And I need to lock both of those. Interest divided by 12. Reference the payment made. The payment lock equals payment and lock it. Principal write down, payment less interest. End balance is beginning balance less principal. Copy and paste all of those down. In cell M10, calculate the total interest paid. Sum of interest. Calculate the difference in the amount of the monthly payment between the 30-year payment and the 15-year payment. So the 30-year, 15-year payment and 30-year payment. How much interest is saved? The interest saved, oh, it should read the instruction. Interest saved by taking a 15-year, okay. That would be $900,000 of interest. Oh wait, click in the box, equals 967 minus 420. Okay. $99.9. 357 of the 360 values are correct. Well, if 357 out of 360 are correct, there must be round off error somewhere, and I bet it's either the first three or the last three. And I won't be able to tell. Calculate the interest owed. 178 out of 180. So there's some kind of little round off error going on in here. And I apologize for that. I'll take the 99.9% and move on.